Mm-hmm.
So it's kind of been like a slow week where like I don't really have anything to work on while I'm printing. I guess I could work on the next project, but it's hard to, like switch gears like back and forth.
So you're just left staring at the printer, like waiting for the layers to finish.
Yeah, exactly. And honestly, like it's not being great because I'm like coming up with ways to like break my project.
Right.
Like, oh, what if I try this, and then I try it and like I'm like, oh no, I have to print another massive part again.
Meanwhile, the printer's already busy, stuck on the project before, and now you have this queue of parts that you just want to make.
Exactly. It's funny because I'm not used to like the outrunning my printers. Normally like I'll print something and then while that's printing, I'll be working on the next part. But I think that because this is kind of like a project that I had finished a long time ago, and we'll actually talk about it today, but and then it was kind of done, so I just had to scale it up and print, and now it's like completely outrun my design process.
Yeah, I had that problem too with the project a little while ago, and then before I knew it, I had like 4 printers, and it was just getting out of control. It was like a bad hobby, too much. So I just scaled back down to 2. How many printers are in your workshop?
So I have 3, 4, like I have 4 and 1 in a box that I still have to open.
Okay.
And then
so you're up there, a little mini factory.
Oh yeah, it's a bad hobby because I've also like I had a couple printers that I had to get rid of, and I have a resin printer that I don't use enough. But then I also just got like this printer right here. You can see there's like a monster part on there right now.
Yeah, it looks pretty generous build volume.
That's it's like 400 by 400 by 500, something crazy like that. Yeah. Which is like, it's great, but it inspired this like massive project, which is what I'm working on now. And
if you have the real estate, you got to use it.
Yeah,
you got to print big.
Exactly. But the problem is I only have one of those printers, and I can't fit any of the parts on any of my other printers. So it's like that's the backlog now. And like like there's a part of me that's like, do I get another one of these big printers? And it's just like no. We got like they're so big, they take up so much time.
Have you ever looked into those belt 3D printers where you could kind of print forever?
Yeah, I've
forever.
Forever. I looked at it more for like the idea of like printing really big thing, like really long things. Like actually, like one of my friends, he has one, and he printed like a full longboard surfboard on one of those.
That's
in sections, and then he glued them all together. But
that's awesome.
It's crazy, but it's the same thing. Like it just ends up taking up so much time. And then you wonder, maybe is this the best way to do it? I don't know.
Right. You can always go back to printing in smaller parts and putting it together, but then you got to worry, are these like failure points now where you're connecting all these?
Yeah, for sure. And also it like just breaking parts up to fit and like fit together is such a time consuming process. And like it's such a grind on SolidWorks. I find like it works, and I've done it many times, but it's definitely a grind.
100%. Yeah, I'm definitely thankful for like the split commands, not just in SolidWorks, but I find in like slicers too now, where they include like pegs.
Yeah,
and just save so much time.
I honestly haven't even messed with in slicers. You can do like pegs now.
I think in Prusa.
Oh, that's amazing. I've only ever done it in SolidWorks. But often, like, I take it a little too far, and I start putting pocket holes on angles, and like, it's a lot. It's a lot. But it
100%.
Honestly though, it like I find the failure points are never really the connections. It's always like the prints themselves. If you're like putting like pins in, like like the metal rods aren't going to be the failure point.
Right. Exactly.
It might be stronger than the rest of the print itself.
100%. And I find the key is you need a good glue to hold prints together. You need some good. I go with, I think it's Loctite.
Okay.
And if my parts break, it usually breaks in a different part than where the glue was.
Yeah.
So
there's a glue called it's called 3D Gloop. I don't know if you've heard of it.
Yeah, 3D Gloop sounds familiar. That's your go-to?
So I just found out about it like recently in June, and then I haven't had a project yet where I've needed to use it, but it would be my go-to. They definitely sold me. Like they had these like demos where they had these like 2 hooks together, and they were like doing tug of war, and the parts were breaking not on the glue joint.
That's awesome.
Yeah.
Well, I'm excited to talk about that and a whole lot more. 3D modeling, 3D designing. Hi, everyone in the chat. Hi, everyone from around the world. Welcome back to this episode of SOLIDWORKS Live Design. I'm your host, Noah, and we have a super, super special guest here today. Someone who's well known in the 3D community for their 3D design skills, their 3D printing skills, just their overall 3D content. It's Jay from JBV Creative. Welcome to the show, Jay.
Thank you, Noah.
Yeah, so we have a lot of stuff we want to get to between designing and printing. Before we dive into that, can you just give us a little background on how you got your start in 3D?
Yeah, so I started with SolidWorks like a long time ago. I graduated university in 2023, so sorry, in 2013, geez. And so it's almost been 10 years. Yeah, time's flying. Wow. Yeah, so it started in school, first year design class. It's funny, like I'll never forget, like just like mates, like what are mates, and like this is just like the craziest thing. It just like blew everyone's mind, and it's just so funny how like it comes so long, like it's like second nature to me now. But yeah, so I started in university, so that would have been 2008, and basically like SolidWorks was probably my favorite thing to do. It's I've always found it's just basically like building, just physical building, but you do it on a screen,
right?
Like slightly different tools, but you have to use that same mentality. And I've always liked building things, and I like the idea of like being exact when I'm building stuff.
Right.
And so I really like dove in deep into SolidWorks. A lot of my jobs over the years were because of my SolidWorks skills, and then it kind of led me to where I am now, because I realized that like I'm half decent at this, and I have these ideas. Like, let's see what happens if I like go full on this kind of stuff. And then that led to like, it's only so great to have it on the screen. I like to see it in the physical world. And so that's where 3D printing came in, and that became basically like my favorite thing to do. Awesome. And now we're here.
Yeah. Well, to say you're half decent, I think is being modest. I've been blown away by the stuff you've created on your channel, and also the 3D printing aspect too. You say bring it to the physical world. Did you find out about 3D modeling first, then 3D printing, or 3D printing first, then kind of the modeling came with it? How did that journey come about?
Yeah, modeling first. 3D printing was like, it's crazy how far it's come in 10 years. But at the time, it was like, when I first started university, it was like we didn't have access to the 3D printer. We had to like make the files and like give it to like the tech, and then like wait a few days, and then it would come back, and like we had no idea what we were doing. But so it was definitely like CAD first. 3D printing came completely second. I actually didn't even get my first 3D printer till it was 2016, I believe. So I didn't know anything about really 3D printing until then. But I think like having the CAD skills first was like a huge bonus for me, because I was able to jump right into like, now I can make anything I want and then make it in the physical world. And I think the CAD skills was kind of like the biggest, like the hardest part.
100%. Yeah, a lot of hours needed to perfect those CAD skills. I would say sometimes you could spend 10 hours designing something just for like a 20-30 minute print, just to get it right. Yeah. But I see this awesome contraption in the background. I'm pretty sure I've seen it from one of your videos before. Are we going to see a little bit of that today? Some of your other stuff? Can you give us an idea of what we can see?
Definitely. Like we're gonna start with like something very simple, which is just like a little, it's got a 3D printed spring in it, so it's not working great, but it's like a little animation.
Awesome.
Inspired by like a clicky pen. And we'll go right into, I got, some of my sculptures, and we're gonna talk about like the design process behind stuff like this, which is a, little
love that
hands up. And we'll talk about gears, and then we'll get into this right here towards the end.
Awesome. Let's do it. And I love the hand. It reminds me of the hand emoji. Let us know in the chat if you throw a hand emoji if you love that creation that Jay's made.
That was actually
let's see
great, the hand emoji.
Yeah. Love that. And do you have the SolidWorks open on that?
I do. So let's pull open SolidWorks, and we're gonna start with let's start here, because this is actually so this right here is, let me grab it, is this piece right here, which is, I designed it. I'm working on a big Rube Goldberg project, so it's going to be tons of mechanisms like this all tied together in a chain reaction. So this right here is just like a slow dropping mechanism. And this is actually a really good example of just like how to get gears to work in SolidWorks. And so let's jump right in here. And you can see I have all of this lined up, and actually like recently I've only started kind of like mapping out how I was going to set everything up before I start designing. But it's kind of like a bit of experience has led me to know like best how to arrange gears and stuff. But one of the biggest things that I use in SolidWorks is gear mates. And so you can see I don't have any of the mates set up here. So let's jump into that right here. And we'll start with this gear train. So I'll hide everything else. I'm just hitting tab on my keyboard. That's like a quick way to hide.
Very useful shortcut. Love that one.
Very useful. Yep. And so right here, we just have a simple compound gear. This is a 45 tooth gear. This is, I believe, a 15 tooth gear. So to mate these two gears together, there's a couple ways to do it, but the way I normally do it is I just grab the center points and I'll hit mate, and I have mate set up to a keyboard shortcut, which is really useful as well. And if you go into mechanical mates here, there's this gear option. And so right now I'm mating this 15 tooth gear with this 45 tooth gear. So right here, it's showing the teeth diameter as like the center hole size. But you can just change that to anything. So I'm going to change that to 45 because there's 45 teeth. And this is 15. And we hit OK on that. And you can see now we have a gear mate. And it actually gives you a really strong representation of the gear ratio. So you can see this is a 15-tooth gear. This is a 45-tooth gear. So if I spin the 15-tooth gear, the 45-tooth gear spins more slowly. And in reverse, you can see if I spin the 45-tooth gear, the 15-tooth gear spins quickly. And that's just like a nice simple gear ratio. So let's open up let's get the rest of the parts showing.
That's awesome. And I love Sean's comment. He says, this is actually very soothing. It's almost kind of like therapeutic sometimes.
Yeah.
Watch all the mates in together.
Yeah. So let's mate these two gears now, and you can get a better idea of what I was trying to achieve here. So we'll just isolate them so we can just see these two parts, and we'll go through the same process. Click those two, mate. Mechanical gear. And it's funny, like I've done this so much that it's kind of become second nature to me. So we're going 45 tooth here, and yeah, I got that right. And then 15 tooth on the other gear. Boom. And we'll hit OK on that. And then now when you look at this, I believe this is all attached. Yeah. So you can see when this is spinning slowly,
wow. We got the whole thing now.
Quickly, exactly. And you see the whole gear train. All right, so it works the same way with bevel gears. Let's just quickly mate these two gears together because they're supposed to be coupled together. And I'll just do that I'll just isolate them so I can see them better in my command tree here. And I'll just pick some planes that work together. It doesn't really matter, but front and front. Sometimes I have these like weird things where I don't want to mate a top and a front. There's no reason for it. It's literally just like, maybe that's the art form of SolidWorks. I don't know. But then, so this is a 2-to-1 gear ratio as well. So if we take these two gears and we'll isolate those so we can look at them, and we can actually just mate the axes of the gears as well. And so I'm going to grab, this one doesn't have an axis, but it doesn't matter because I can just grab this. There's so many different ways to do the stuff like this in SolidWorks. And
so choosing the curved face will automatically select that axis for you.
Exactly.
Right? Okay.
Yeah. So I could choose this. I could choose the inside. And for gear mates, it doesn't really matter because they're more just for me to like see how things are going to move around. And, you know, I could do like, I believe this is a 20 and a 40-tooth gear, but I also know it's 2-to-1. So I could just say like, this is 1 and this is 2 because it's mainly the ratio. It's not the necessarily, you know, the size of the gears. It's mainly the ratio. So 2 millimeters to 1 millimeter. It's all the same as far as SOLIDWORKS is concerned. So we'll hit OK. And you can see now we have that mate working. So if we look at the whole thing now, and I believe I might need to mate this. Yeah, let me just do one last mate here. We can mate this hook. And sometimes when I isolate, it's just because it just shows me in the feature tree here, like the two that are showing, and it's just easier to catch what you're looking for. And this will go, I guess we're gonna have to suck it up and go front plane and top plane. That's okay. It's all good. So now these are coupled together, and when we look at the whole thing now, it's basically a full working mechanical assembly. Yeah.
Wow. Someone get the stopwatch out. That was what, just a couple minutes to get all of these parts moving together?
Yeah, and it's actually interesting, like, you know, I've done this so much now that this whole thing, start to finish, took me like probably under 2 hours to design.
Wow.
You know, with a couple mistakes. There's always mistakes that, you know, I only really catch them after I've printed everything out, obviously.
Right.
That's something that we can talk about a little bit later, is what I do when that happens. And like, you know, sometimes like when I'm designing, this is like just a little thing. Like I didn't have this piece originally, but I knew I might need something to act as a stopper. So I just added a bunch of holes in the front here so I could just like attach accessories. And so that's what those holes are for. But yeah, so basically the reason why I designed this part this way is I wanted this piece right here to move really quickly when this was moving not that quick. And I think I might have messed up the gear ratio somewhere because it's not moving as quickly as it's supposed to.
You had mentioned you don't have to put in the exact number of teeth to match up gears, right? Just that ratio should get the job done.
Did I get that ratio backwards though? I might have. But whatever, we'll just move on. You gotta just trust me, because in real life, it works.
Right, we trust you.
Under pressure, it's, you know, I don't know. I don't do CAD under pressure very often, but as you can see, as this moves down a little bit, the top, this governor is moving a lot, and what that does is it slows this whole thing down.
Right.
So if I had a screwdriver with me, which I do right here, I can show you. Oh my god. As soon as I remove the governor, this handle drops really quickly.
Oh wow!
So that governor makes a huge difference.
Yeah.
So it's cool to see it in the CAD world, you know. But for me, I get the most excited when it becomes the real world. And I'm like very driven by that. Like I move very quickly just to get things out into the real world as fast as possible. Let me just try to get this screw off of my keyboard.
Yeah, and we also have a question in the chat too, because looking at these gears, we've seen a lot of your other projects that have, you know, maybe not the same exact gear system, but something like that. Do you design all of these gears from scratch each time, or do you recycle those designs?
So yeah, all my gears mainly come. I have a gear library that I compiled.
Okay.
It was before I used to use the toolbox in SolidWorks, but there was a period of time where I didn't have access to the toolbox, so I just compiled a huge gear library, and it's actually available on my website if you wanted to use it. It's free. And I just pull gears from that library, and then, you know, for compound gears, I'll just insert. Can show you here. I just insert the part into another part. So like here, I just had the 15-tooth gear in. I pull this part in, and then you can actually mate it in the context of a part as if it's like a regular part. So I got this concentric mate and the face mate, and then I just combine them, and now we have a single part that I can export as an STL and 3D print. So that's kind of my process. It's all comes from that gear library, which is, yeah, if you want it, it's available on my website for free.
That's awesome. So that's interesting. This is actually two different models that you combine together and printed as one.
Exactly.
Okay.
Yes.
Very cool.
So it's kind of you know, I think sometimes I use like full, like, what's it called? Multi-body parts. So like this is actually an example of a multi-body part, where I've designed all these parts together in the same part file. And then when I export them, like, there's multiple bodies. And the reason why I do it like this is because these are static. So I basically only assemble like assembly parts that are going to be moving in the assembly, and otherwise I use static parts. And from what I understand, there's not really like a best practice necessarily. It's just there's so many ways to do the same thing in SolidWorks. Mm-hmm. And so this is just a way that it keeps it simpler for me. Like in the feature tree here, there's just like less features, and I don't know, I just find that helps.
Yeah, definitely try to save digital real estate where you can, especially when these contraptions get so complicated. You have so many different moving parts.
Exactly, and it's also like a mental real estate as well.
Yeah,
just I don't know, different ways to categorize, but everyone's got their way of doing it, which is I find that very interesting with SolidWorks, because there's just so many ways to accomplish the same things.
Absolutely.
So that is, this is, as far as gear trains are concerned, this is a relatively simple gear train. It's just compound gears that are speeding up from here to here. And it's kind of like, just one building on the next. And so that's how we got in here. So I think we can close this file and we can move on to the next one.
Let's do it. We also have another question in the chat, and I'm curious about this one as well, because a lot of this stuff that you end up creating, I know you try to match the digital and the physical world as best you can with these assemblies. Is it always a quick transition, or do you find that you have to print a couple times to get that tolerance right?
As far as tolerances are concerned, now I just know the tolerances that work. Like in like gears like this, it's often I'll just add like 0.1 millimeters outside of like the usual like theoretical distance that they're supposed to be, and that always seems to work well. Right. For like sliding parts, I have my just like different, depending on what it is. Like for something like this, we have sliding parts, and there's gears and like pins and stuff like that. Mm-hmm. And then I designed this specifically so it can be printed on any 3D printer. So I have tolerances that I use for that, and it's just become kind of like an experience and like just doing it so many times that I know what tolerances to use, and we can actually talk about that as we keep moving forward. So let's move on to this actually, because that's a really good example of like a lot of different mechanical things and tolerances going on. So here it is here. I'm just going to hide some of these sketches just so they don't get confusing. So, you know what? Speaking of tolerances, let's start with the tolerances of this pen right here. So this pen is kind of like a standard that I've developed for all of my like design for print parts. It's a 7 millimeter pin, and then the holes are all 7.4 millimeters. So there's a 0.2 millimeter tolerance around all sides, and that has really seemed to work well. And like, it's kind of interesting thing to think about actually. Let's look at this part. So this is the base, and I've designed this part to print this side on the bed. And so we can actually use like a section view to kind of take a look at how it prints. So if I pull this up, this is kind of like the layers as it prints.
Yeah.
This is,
so I sometimes see any overhangs here.
Exactly, overhangs. Like there's an overhang right there.
Yep.
And there's one right there. And, so I use this to kind of like get a quick idea of like how things are going to print. But you can see these holes right here are printed like vertically. So there's an overhang on the top of these holes. And then when we go back to the assembly, you can see this pin is going through it this way. And so that 0.2 millimeter clearance allows for, like the kind of funny business that happens on the top of these overhangs.
Right.
And you can see in the actual part here that it doesn't have any problems. It's actually like, it works. Is it focusing? Yeah, it's kind of focusing. It gives you enough clearance for that to actually work well.
So you're saying the layers that are printed at the very top of that overhang,
yeah,
you're anticipating they're going to drop a bit.
Exactly.
So you're going to you're including a tolerance basically to account for that. I call it droopage. I don't know if that's a technical term for it.
That's a great technical term. So
Yeah.
Here, I can't get it undone. Like it's kind of jammed, but let's see if we can see the droopage. Like right here. Let me see if I can use this, where I'm pointing right
Yes.
there.
The trusty headphone jack.
Trusty headphone jack. So that part is an overhang, which I didn't use any support material, and that was by design. You can see it kind of droops a tiny bit, but it's fine. Like, you know, for what it is, it's perfectly fine. So one thing to keep in mind, though, is when you're doing stuff with like 3D printable tolerances, like everything's kind of loose. You know, it's not the most ideal if you're trying to create like a, you know, like a perfect assembly. And that's why there's certain things like, you know, like on this shaft, I added these side flanges to give these gears like a little bit less wiggle. And so if we jump into CAD, you can see better what I'm talking about. It's these side flanges right here, which I gave to support the gears, where if these gears were like supported by like bearings and threads, like you could get away without these because the clearances are way tighter. And let me see if there's a good example here of I've really like come to love bearings and like M4 screws have become like, you know, my go-to. Like everything that I do now is like I have bearings, and then like this M4 threaded screw will go like right into the bearing, and then it will screw directly, oh my god, into the part. You know, and
I see. Okay.
Right into the part, and I can crank it pretty tight without it stripping, and that gives me like a really tight tolerance, which has been really nice because I, you know, for the first 2 years I was doing this, I was designing everything only for 3D printing.
Right.
So everything had like a lot of wiggle to it, and now I'm like, you know, everything's very precise, and like it's really like there's not a lot of wiggle, and it's just such a nice thing to create mechanical assemblies that are, you know, like really like perfect. But
and do you print all of these parts in PLA, standard PLA?
So this is all PLA plus.
Okay.
And yeah, the reason I use PLA plus is, I don't know, I like, someone gave it to me like as a sample, and it just works really well and looks really good, and I've never needed anything else. That being said, like I don't know what the life of these mechanical parts is, you know, like I don't know how, like if like maybe like the threads will eventually like loosen or whatever. I kind of just make projects then move on like pretty quickly.
Right.
But yeah, let's talk about some of the mechanics in this and how I've accomplished some of the things, because there's actually like an interesting feature in SOLIDWORKS that I've only started using recently. So basically this is a barrel cam, and the way it works is as this turns, it pushes this little knob right here up, and then that transmits through these pegs or whatever you want to call these, I don't know the technical term, and that pushes up the arms. So when I'm modeling this barrel cam, I've never done this before, and you know, so like luckily this is a very small part, but if it was bigger, I'd want to get a better idea of like how it would work, how it's going to push things up. So one thing you can do, and because this is kind of like a weird geometry, like this, if we take a closer look at this, I use like a wrap feature, which is actually, this is the first time I've used the wrap feature, and it's very useful. Basically what that means is I can take this sketch right here, and you can see I sketched out this profile, and then it wraps it onto the face. And that's how we got this right here. So awesome. This wrap feature doesn't really work that well with mechanical mates, you know, and like there is a mate, and if we look at the mates tab here, there is a mechanical mate called a cam mate, and that is, it would be ideal for this, but this face just doesn't work with this mate. And there's like not really anything that I can like use to do that. But SOLIDWORKS has this really interesting, let me just save everything because sometimes my computer breaks when I use this feature. Just my computer doesn't have the power. But
definitely approach it there. Save every every chance you can.
That get like, you know, Control S for me is like a habitual thing. I'm constantly hitting it. But we can use this move component feature. And then there's this physical dynamics, which is really useful. It contains limit mates. So let me just get rid of the limit mates because those are completely different. And we'll talk about what that could be before, but we'll just suppress that limit mate. Let's see if we're good now. Move components, physical dynamics. Okay, you know what we're going to do? We're going to delete the limit mate.
All right. One way or another.
We don't need it. Save. Let's see if it's still going to give me that problem. No, we're good. Okay, so I can check physical dynamics between two components. So we're going to check this component and this component. And what that means is it's going to know when things are moving together. And you can actually run gears with the physical dynamics as well. So it's kind of like an alternative when the mechanical mates are just not doing what they're supposed to do. But so if we resume drag, and let's just cross our fingers that nothing freezes, I can drag this, and you can see that it kind of gives me an idea how things are going to move. And
that's awesome.
What's actually happening is this piece is actually moving on this surface, which is the way it's intended to work in real life. And it's giving me a good idea of like how hard it's going to push the arms up and how far it's going to go. And actually just out of like kind of like a, you know, just a little bit of a side tangent, the reason why I added this flat surface here on this mate was because I wanted the physical sculpture to be able to stay in its up position or in its down position. So as it comes all the way up to the top, it gets stuck on that point, and you can it stays there. And then the only way to get it down is to hit the down lever. But so it's given me that exact motion, and I knew I had some confidence with this that it was going to work in real life. And so that's kind of a really amazing feature that really I've only been using for like the past year. I didn't know it existed before.
Awesome. It's great to see even someone who has years of SOLIDWORKS experience like yourself is still, you know, getting to learn some of these new features and mates. We also have another question in the chat. Seeing all these moving components, do you ever stress analyze any of this movement?
Never.
Just so like, find out.
Yeah, you know, like I think, you know, I go on a little bit of experience, but also none of this stuff is, I'm not really dealing with stresses on this kind of stuff. Mm-hmm. Funny enough, though, that being said, I actually just took this sculpture and supersized it by 600%.
600%.
Actually more, 750%.
Okay. There's some stresses there.
So we're gonna learn the hard way whether or not there's stresses and strains. Let me grab the piece so you can see the scale of it.
Let's do it.
Right here. I'm just connected by this wire, so I'm trying to be careful. And this is a little sneak peek of my next YouTube video that I've been working on. But this is the hand. Wow. This is the arm. Sweet. The hand goes on. Get my microphone just fell. Hold on.
Oh, you're good.
Okay. So you can see the scale difference. This is what I designed it for. Mm-hmm. This is where it's going.
Just a little bit bigger.
A little bit bigger, but it seems to be strong enough to hold. And I think sometimes, like, you know, learn by doing is the best way to go. And that's kind of, you know, like this is the first time I've scaled up something this big. So I'm learning a lot about what it takes to scale something up. It's not as simple as just like scale. You know, I'm like changing the bearings that I'm using, the connections, and the way that I'm making these connections and stuff like that. So it's kind of a learning process still. And I think it's kind of going to have to be like, if I try to do something and I can't get it to work, then I start to look into like more advanced tools to help me figure out how to get it to work. Mm-hmm. You know, and I think for now we're good. Also, I'm not sure like how to 100% do stress analyses on 3D printed parts because they're not solid pieces. And I think that makes a little bit more complication, but definitely something to look into if I need to in the future.
Definitely depends on their orientation as well. That's a great point. So I'm just thinking about it in my head because when I first saw that contraption, the things that you were using, they look like pedals, to step on. Is that kind of what you're going to be able to do when you make this huge creation, kind of walk on it?
No, it's actually just going to be
totally wrong.
Well, it's going to be this. It's not going to be that big, ultimately. Like the pedals are. Should I just grab it? I'm just going to grab it. Just give me
Why
one
not?
second.
Why not?
It's honestly, I'm very impressed by the scale of this. I've never seen any of my projects this big. So sneak peek for everyone.
All right.
Oh my God. It's heavy though.
Special world premiere. Oh, wow.
There it is right there.
That is awesome. And how much plastic is that?
I
guess how many spools?
It's like 6 kilos. So 2-3 kilo spools so far.
Wow. Like well, for everyone in the chat, this is a special sneak preview.
Yeah. Just
an unbelievable project.
Is it's like 2.2 kilos. But you can see these paddles are not big enough for like feet. They're like
right.
They're full hand paddles. So it's gonna sit on top of like a pedestal, and like I'm actually making this. There's like a huge art festival in Toronto next weekend, and so this is gonna be out in public, and people are gonna be able to like activate it, and hopefully it holds up. I think it will. It's pretty strong, but we'll find out.
That's so awesome, and what a cool way to showcase it too. At a festival.
It's actually like it's fun because like it's nice to have like a real reason to make something, especially something this big. Like it's a big commitment, and I like almost messed up the base, and I would if I would have had to reprint that, it's like a whole 2 kilograms, like 2 full days of printing. So it's good to have like a real reason to be making stuff like this.
Yeah.
Outside of just like sharing it on the internet, which is cool. I mean, it reaches a lot of people, but it's cool for it to be in the real world as well.
Yeah. No, if I had a reason to print a giant hand, I would be all over that. That thing is awesome.
Yeah, for sure.
Just reeling it back a little bit, we did get a question in the chat. What is some of your advice for someone first trying to get into designing these crazy contraptions, getting into the design mechanical field? Do you have any advice for people like that?
Yeah, definitely. I think the advice is to just remember that you have to take it one step at a time, always. Right. So all my projects start as like a sketch or an idea, and it's just a matter of like, like what do I need? How do I need to make this? And like, what's like the first step to take? And then what's the step next after that and after that? So it's the same thing with learning how to design. Like if you can learn how to do one simple gear mesh, that's like a good place to start. So you learn how to bring 2 gears in, how to space them, how to use the gear mate to get them to work. And that's like a fundamental that I use in every single one of my projects. So another one is like just like a fundamental is like just like a pin and a slot. If you can get a pin and a slot to work, it's like like I would imagine, it's not the easiest thing to just open SOLIDWORKS and make a pin and a slot, but I think it's a good first project to start on because it teaches you some of the fundamentals. I can jump into SOLIDWORKS and just show like the real basics of it. So if we open a new file, and we want to make a pin, it's really as simple as making a sketch, a circle, circle, give it a dimension. We'll do 7 millimeters. And then you extrude it. And so now we have ourselves a pin. And like, this is like the thing that I always stress is like stuff like this is very simple and easy to do in SOLIDWORKS. Within 10 seconds, we have a pin. And it's like a very basic pin, but it counts. And then if we wanted to put a slot around this, we make a sketch on this face, draw a circle there. And then this is where we can pick our clearances. So like here, I always use a 0.2 clearance for a sliding part like this. Now we got to give the part a wall. And if I'm 3D printing this, like, my printers are normally have a 0.4 millimeter nozzle. So like the minimum that I can make this is 0.8, which is 2 layer lines around. And then we can extrude that. And we'll go this way just for fun. And so now we have a pin and slot. And like, this is very basic, but this is something that I use so often in all of my parts. So if you're trying to start out, just remember that all these big, crazy looking contraptions that I make are all built off of fundamentals. So you start with the fundamentals and then you go from there. Awesome. That's my advice.
Great advice. Thank you for that. And also, I don't want to take away from this amazing Rube Goldberg contraption that you have to share with us. So I want to make sure we get to talk about that at some point, because mean, I could see it behind you. It's staring me in the face like, what is this thing?
Yeah, we'll get there. We're on the path. So, okay, I think let's talk about how much time do we have? Another 20 minutes?
Yep.
Okay, let's just get rid of this. Don't save. We don't need that. We can close this. Boom. Control S is so key. This, we can come back to this if we want. This is kind of like a side quest. So we'll talk about this first, because this shows a couple more mechanical principles that you can do with SOLIDWORKS. And it actually comes back to the theme of just fundamentals built together. So this is like a ball contraption, and it was like meant to be like kind of like an animated GIF, but like in the real world.
One of those satisfying ones that goes on forever.
Exactly. So this ball will just keep going around forever and ever. I did see Aryan mention pathmates. So this ball is actually on a pathmate, which basically just means if I can find the path, the track, this path right here, the ball is mated to this sketch right here.
Oh, I see. Okay.
Yeah. And that just kind of allows me to get an idea of like how the ball is going to roll, you know, like how much clearance I have with the track pieces, stuff like that, you know, and like where it's going to end up on this end with this arm that lifts it up. So that's a good trick. And if we just look at the path mate, let me just find it for you. The path mate is a really simple thing. It's really just a point mated to a sketch. And so this is a closed loop, which is this path right here, and the point is the ball. So it just keeps that point on that sketch, really allows you to get a good idea for how things are going to move.
This is telling me I have so much more to experiment with pathmates. I've never even thought to use it like this. That's awesome.
Yeah, you know, actually, this is like really the main place where I use pathmates. Aryan was saying in the cam where I was showing the physical dynamics, but I just couldn't figure out how to get a path in that point. It was breaking the assembly at the time, so that's why I ended up using physical dynamics. But another cool principle is this right here, the scissor mechanism, which is a really simple, you know, this is actually, if you're looking for like a fun first project to design, the scissor mechanism is a great idea because it's just built off of really simple things. So it's basically just, I'm using concentric mates to hold these together at these points. And then it gets a little bit more complicated in, I have some gears at the end, and these are gear mated together the way that I showed before. And that allows this to move up and down, you know, like in this uniform fashion. Right. And where this gets a little bit more complicated is I'm using a cam mate on this cam to drive the scissor mechanism up and down. Oops. So what that means, if we show that cam mate, basically, it's right here. It's the cam path is the outer profile of the cam, which is this right here. And the follower is the face of this. And that just basically means it's going to keep these mated tangentially. So as you move, let's close that. As this moves, it's going to keep this and this touching. And that actually gives me an exact feeling for how this cam is going to move the scissors up and down. If we zoom out a little bit and we show this, the whole thing I was trying to go for was as it comes up, it dwells here for a second. And then as it keeps rotating, it drops and dwells here for a second. And I was trying to time it with the arm motion so that this would come up right as the ball gets dropped, and it would kind of like build a little bit of suspense. And then it would drop down right as the ball was about to drop down, just keeping that suspense going, and it would just repeat forever. If you want to see a video of this, I I used all the electronics that I had on that project for something else. But if you wanted to see it in real life, it's right here.
Wow, look at that. That is so cool.
We can see like as this rotates, it goes this way. You can see like everything is coupled together.
So is all of this tied to one motor's movement?
Yes, exactly.
Wow.
It's all tied to the motor, which is here in this box, and it's all connected through this gear train. And the gear train is just, like the same basics of gears that we talked about. And then the last thing that's kind of interesting about this, which is this is actually something I'm still trying to really dial in, is the SOLIDWORKS gives you the ability to do chain mates. So this is a pattern that is built off of one single link. Let me see if I can find it for you right here. And basically you pull the link in, and then you can pick where like the faces of the different parts of the chain connect, and then it automatically fills it based on the sketch that I have set up right here. So this is the sketch, and that's what builds the chain is built off of. And then you can actually like rotate the chain around too.
Oh, wow, yeah.
Cool. And there is a way to mate the sprockets to the chain, but it's a little bit of like a, like a backwards way of doing it. So I kind of just like wing it. Where I'm still trying to get dialed in here is just like spacing, and like you can see this chain has like a little bit of droop on it in the real world, And this is like something that's really important to remember is like, I have this gap right here, which I was trying to use this gap to pull the tension in. And just the way that I have these sprockets designed, the way that these parts are designed, it still has too much tension, And so I'm still trying to figure out like exactly how to space sprockets apart. It's a process of learning. I've done many different like chain and sprockets, like at least 6 different ones, and I still haven't quite figured it out. But it's a process. I had something in here to try to like tension the chain. If I can, I think it was this sprocket here. Where are you? Unsuppressed. Yeah, you can see it's just giving me problems. But I ran out of space here, and it just wasn't working the way I wanted it to. So I just completely removed that from the final design, but it's still there.
That is so cool. And it's so awesome that you take into account the real life, I guess the real life physics of what's going to happen with this chain. Does that also go hand in hand with how you time up all of these things to move together?
Yeah, like, so in theory, this chain should basically tie the bottom sprocket to the top sprocket, like exactly. Okay. In retrospect, there's like a little bit of a gap, but again, like everything that I make is not like, I don't need it to be precision. So I do have a little bit of breathing room here, but that's kind of like, like I have this cam is timed to this sprocket because they're driven through these gears. And this sprocket is timed to this arm through the chain. So technically everything works together. And right now I don't have it set up in CAD, but in the real world, you can see that as let me get a ball actually in here so you can really get a feel for it. So as the ball comes up, you can see the scissor mechanism rises, right, and kind of like perfectly times it, and it would keep rotating, and it would come around like that, and then this arm would keep going and catch the ball. So if you can do it smoothly, you would actually be able to get like a full, like proper rotation. But obviously it's hard to do.
I could just see it. I could just see myself staring at that all day if it's actually going up and down. And if I remember correctly, I saw this video that you posted, and the first time you made that arm, wasn't it straight?
I tried like a whole bunch of different iterations on the arm. If actually we can like, let's see. You can see all the iterations if I open the file for this.
Let's see, because I'm curious, when you're making a project like that, how many iterations do you go through?
Like, so this was actually kind of interesting. Like, I try I try to design stuff so like the track, for example, was the thing that was the hardest for me to build. And so I desperately did not want to redo it. So I ended up creating a couple of changes to fix some of the problems. And that was like, you can see here, this sensor did not exist there in the first place. I added this after because I needed the track to be a little bit longer to perfectly sync up with the arm, but I just like didn't want to redesign the track. And so the iteration was like, that was why I went through so many attempts at trying to like change the arm. And then like, you know, like last minute, I like added a sensor to try to fix it. So the process, the iterative process is interesting because it's like you could do a lot of things before you have to do a full redesign of the entire project. And I try to like minimize my like waste and, you know, like time waste as well. But it really just like 3D printing waste, like the biggest parts, I try to make it so I don't have to reprint those big parts. Like if that makes any sense.
That definitely makes sense. Huge time
So
saver.
yeah. So that was why the arm, I went through so many iterations. Let's see, like you can see 1, 2, 3, 4, 5.
Oh,
6.
wow.
Just trying different things because these pieces are like, you know, let's look at the big view, extra large icons. Where are those arms? I was changing like the curve and like changing the length. And I was really just, you know, because these are like, you know, like 25-minute prints on the Bamboo Lab, which
looks
is
like at one point you had a double arm. Is that right in the top right?
Yeah, a double arm. I thought that was maybe my problem. And it's just kind of experimentation, just trying to figure out, like often I'll just like stare at the thing and like, you know, keep trying to figure out ways to adjust it without having to like redo the whole thing. From Chris, I see a question: how do I time the mechanisms? In this one, I like added this. How do I get back to SOLIDWORKS? I added the splines here in the arms, and there's like different splines in the sprockets. If we take a quick peek at the sprocket, and this way I was able to slightly adjust the timing in the real world to try to get it perfectly timed. So sometimes it's like, you know, with a lot of thought and effort, but often it's a lot of like trial and error experimentation. Right. And then I have a lot of this experimentation that I can draw upon from previous projects that I can now, it allows me to help move things in like in the future projects.
Gotcha. And we also just got a question in the chat. Do you ever use configurations to go back and forth quicker?
I do. I don't often use configurations in assemblies. Maybe I could more, but I've just found like it's easy enough to just like replace a file, especially if it's got the same like base components. I can replace a file. So like for this, I was often like, you know, you can replace components, and then if I just pick like another arm, let's just go with like, I don't know, let's go with this small guy right here. You can see it just drops the part right in with all the mates already there. And so sometimes it's just easier to do that than trying to like, you know, pick which parts are configured in, you know, which configuration. But I will use configurations in static part files very often, actually. And like, all right, let's open up this piece right here so we can take a closer look. I just got to close everything down because otherwise my computer will break.
And just to address another question that came in the chat, are you using parametric modeling in your designs? And if so, how useful for it? I believe all of this is parametric modeling. Is that right, Jay?
Absolutely everything. I am like a stickler for fully constrained sketches because that allows you to like, you know, like make changes without breaking everything. So yeah, everything is parametric. I think that's, you know, that's kind of SOLIDWORKS thing is parametric modeling. Let's pull this open. Where is it? Sure. I was like as organized as I could possibly be. And I think it's in here. No, it's Chevy Chev 1. And it is this assembly right here. Okay, so this big dog right here.
Wow.
So speaking of configurations, all of these links are built off of like configurations, and it's kind of like a way for me to, you can see all these different configurations, different size links, which basically means I can use this exact same geometry and just change one dimension and see like there's a couple of differences. You know, like this one has 2 bearings, well, this one has 2 screw holes. And so just like really easy ways to, on geometry that's pretty similar, not have to remake a whole part. So this was actually, just see this message about motion analysis, was one of the first times where I actually used the motion analysis. And you can see there's a couple motion studies. So let's just pull open. Let's show all these track parts, and then we can look at the motion analysis here that I used. Show. And it's actually funny. So the reason why I made this is my big Rube Goldberg project is going to be made of a bunch of mechanisms like this, you know, that are doing different things. And I wanted to test this mechanism right here, which is the Chebyshev straight line mechanism. You can see that this rotation causes this piston kind of thing to go up and down. Mm-hmm. And so I really wanted to just test this mechanism. I was about to print the whole thing out, and I had, like, you know, if we look at the track, I had a couple sections of track that I was going to just test for the mechanism. It was basically, that piece is actually the one that I had. Come on. And so I figured I might as well make it a loop. And then at that point, I was like, well, I need a way to stop it from like continually spinning. So that's how this got all crazy like this. But to figure out if the track was going to work, I actually used a motion analysis, a motion study. This is basic. This is this comes with, I believe it comes with SOLIDWORKS like natively, and you can see here. Let's see if it still works. But nope, that's not it. It might be this one.
She's trying to push up the ball.
I don't know which one it is. I might have like changed some things since this was actually working, and it's going to be a challenge for us to get it to work again. But
that's all right. But you had used motion analysis to plan all this out. We also have another question. Do you also use 2D sketches to plan out, you know, the movement of each of these parts?
Yeah, absolutely everything in SolidWorks starts with a 2D sketch. So if we look at this track, for example, the first thing I did was I started with this sketch. And I think the question said, like, how do I choose dimensions? How do I manage sizes? Often in a project, there's something that will constrain the dimensions. So in this, I started with the ball, and the ball is just like a physical ball, which I don't know where it is right now, but it's a 50 millimeter ball. And it's something
that 3D printed, or?
I mean, I'm just going to grab this ball so you can see it. This one actually is 3D printed, but I have like a wooden ball that I'm going to be using for the entire Rube Goldberg project. But this is a 3D printed ball, just like a little side tangent if you want to see how I make something perfectly round like this. Actually, Steven from 3D Printer Academy, who I think is here, I glued it, but there's a screw in the center, and these 2 screw on either side, and that's how you end up with like a perfect.
Because I was wondering, do you have support on the bottom? Because that looks perfectly round.
Yeah, there's no supports used. It's just half and then screwed together, and I glued it just so it stayed stuck together. But it's actually like, it's very like solid. It rolls like pretty true, which is very interesting. But yeah, so for this Rube Goldberg project, like everything is built off of the size of this ball, and that's this first sketch. I use the ball, which is this 50, it's like a 2-inch ball, so it's 50.8 millimeters, to determine the size of the tracks. And then everything works off of that. So you can see, like, sorry, go ahead.
I was just going to say, as this is loading, our chat's curious, are these files public if they want to take a closer look at how these mechanisms work, or can they find on the website, or what's the deal there?
Generally, I keep these files kind of like proprietary at this point in time. I think I don't really know what I'm going to do with it. It's just like sharing stuff requires actually like a whole lot of it. It just takes a lot of work. Right. And like,
that being said, though, there are plenty of other of those smaller contraptions that you've made that are public, right?
Yeah, but mainly it's just the STL. So if you want to print it yourself. But I'm thinking, like, I'm rethinking my whole Patreon structure that maybe it will offer like the ability to see the actual download files. I haven't figured that part out yet. I'm very much like, you know, I just do the CAD and just like try to make the things, and then, you know, I don't spend as much time thinking about how to distribute and whatever. But it will definitely be something that I think more about moving forward for sure. So I appreciate if anyone has any like requests or tips or whatever, shoot me a message on Instagram and we can chat about it for sure. But yeah, let's get back into this Chevy Chev, because there's actually like a really interesting thing that came out of it, which was, as you can see, when it gets to the top here in CAD, it's like a very defined spot that it gets to. But like, I can't really see when this is here through CAD. I can't see like the flex or any of like the whatever that's in this. And when you have links in positions like this, you know, where the link is moving like not that much and there's not a lot of motion, it's kind of like a singularity. I actually don't know what the exact technical term is. There's a situation where you can get some flex here. And I want to show you that in the real world application of it. So let's take a look. I'm going to pull my camera over. Apologies if you lose me in the audio, but let's just take this over here. Boom. Awesome. Oh, you lost my audio, but can you still hear me?
We can still hear you.
Okay, great. So you can see when it's in this top position. Mm-hmm. I just want to... Up here, there's tons of flex in the parts. You can...
Okay.
Can you see how it's flexing?
Yeah. Mm-hmm.
So it's interesting is like this piston, for all intents and purposes, is high enough to drop the ball into the top track. But sometimes the ball doesn't quite make it.
Okay.
That's one of those things that, like, you know, if I were to do a second iteration, let me just put this back here for a second. But if I were to do a second iteration of this, I would adjust the length of the track. But that's just one of those situations where, like, you can't really foresee it without building it. Or, you know, I now have a little bit more experience to know that, like, because it's at kind of like a singularity point, it's something that is something to watch for in the future. Definitely. Which is kind of an interesting thing that, like, you know, the real world and the CAD world, they translate quite well actually, but sometimes they don't. And
right.
You know,
I think it was something you had said, the digital world, it's the CAD world and the physical world are at odds with each other.
Sometimes they are, for sure. I mean, I'm sure there are ways in SolidWorks to simulate this flex and all this stuff, but I think at some point you have to bring this into the real world, and at some point you have to learn some real world, you know, just like the way things are going to work in the real world. And so I find it's just easier to just build it and learn through doing. Gotcha. It's funny, I worked with a guy who was like, he could design literally anything in CAD, you know, like the most complicated, craziest mechanical assemblies that you've ever seen, but he never spent any time thinking about how to build it. And for me, I was like a prototype builder. So every time I would see his stuff, I'd be like, this is awesome. It's like genius, but there's no way we're going to be able to build this. Right. And then there's even less way that we're going to be able to like mass produce this. I was working for a toy company. So it's very important to always remember what you're like, where it's going, like what the final, you know, product is going to be. Because if you can't build it in the real world, and that's what you're intending to do, then there's just like no point in like doing some crazy wild idea if it's just not going to work. I mean, it's very different if you're designing mechanical things for like the metaverse, like you get a lot more freedom, I guess. But for me personally, I just think there's just so much joy in being able to like physically hold something like this in my hands, you know, and just like play around with it.
Oh yeah, 100%.
Yeah.
And that's also just great culminating advice too. It's interesting to see you've merged the two worlds so much that as you're designing, you know exactly how, like you said, you know your nozzle is 0.4 millimeters. So you need to make it 0.8. So you know you have two lines of extrusion. So is it fair to say that those two worlds, the manufacturing world, the digital world, have kind of combined for you?
100%. And I think for like anyone engineering stuff for like the products, in the real world, which is like, I think most engineers are designing products for the real world at this point. I think that like designing for whatever manufacturing method you have in mind from the get-go saves a lot of like energy down the road, because you can start with that in mind. It's not like you have some crazy design and then you're trying to like modify it to make it manufacturable. And so for me, like I always design with 3D printing in mind. Actually, there's a very good example inside this right here, which if I open it, it's like this spring right here. And this spring is kind of like, obviously it's not the best material for a spring because it deforms and stays deformed, but I designed this to be printed on a regular FDM machine. And so you can see I like had to make a flat spot on the bottom. Maybe it's best I pull it over and pad.
And no support on this part?
No support on this part. You kind of just, you know, and there's like a little bit of that droop that we were talking about.
Yeah.
You look at the, you know,
some droopage. Yeah.
There's some droopage, but it doesn't matter. It works still. And it's just one of those examples. Like if you think about the method of manufacturing while you're designing, you can actually do some pretty crazy things. And like this spring was like the first time where I thought to do a spring like this, and it works actually quite well. And I think if I had printed this in like a PETG or like ABS, it would actually maintain its shape, because it's PLA, it doesn't. But that's a whole other thing.
Whole other episode.
Yeah.
Well, we are at the top of the hour. We're actually a little bit past the top of the hour. I'm sorry I kept you a little longer. I'm so curious about your creative process, and so is everyone in the chat. Are there any last parting words you want to give about your process? Anything you want to shout out, where we could find these awesome creations that you've made?
I don't know if I have any more parting words. I feel like I've talked enough in this episode. But if you want to see some of my stuff, this is actually like this piece, like a file you can download from my website for free and like play around with. And then I have some of my more like, you know, like intricate stuff available for purchase. This actually doesn't exist yet on the internet, but it will in the next couple of weeks. So check out jbvcreative.com. That's where all my STLs are. And yeah, if you ever like have any questions or anything like that, feel free to reach out to me on Instagram. I'm always happy to chat about engineering and design. And otherwise, I think that might be it.
That's awesome, Jay. Thanks so much again for hopping on the show. As you mentioned, if you haven't been following JBV Creative, you're missing out. Definitely hit that subscribe button on his channel to see some of his awesome creations. And we also have a plug for our next SOLIDWORKS Live episode coming up at the end of the month, which is one of our most popular episodes. It's What's New with SOLIDWORKS 2024. So join us and our team of SOLIDWORKS experts as we walk through the latest and greatest capabilities that are going to be available with SOLIDWORKS 2024. And also note, this is a special Wednesday episode of SOLIDWORKS Live. So hit the subscribe button to make sure you don't miss that. And thanks everyone for tuning into this episode. Jay, thank you again for joining us, and have a great weekend, everyone.
Yeah, thank you so much for having me, and thanks everyone for tuning in. Appreciate it.
Awesome.